Okay, 7-2. Solving exponential equations. Before I even flip to the next slide, I got a question.
Square.
X equals 3. Why? 2 cubed is 8. Okay. Everybody see that logic? Follow along. Follow along. Okay. So you're solving these equations, right? That's what it says. Solving exponential equations.
So that's how question gonna be?
Okay.
You don't give us the number.
Okay. But that's the format. That's the properties. Okay. That's how this works. Okay. That's how this property works. So, if you look at the example line down here, if 3 to the x equals 3 to the 5th, x has to equal 5. You have to make your bases be the exact same number. You remember in chapter 6, the day I gave you that pop quiz over the numbers, and I told you guys that going from left to right was easy, but going from right to left is what I really need you to do. You remember that? That's not just applied to chapter 6, that's applied to this chapter as well. Okay? Because in order to work these questions, you have to be able to turn all these numbers that have these perfect bases, perfect squares, perfect cubes, whatever, into bases to exponents. Because that's how you're going to make these equations go. Okay? And honestly, this slide, it kind of shows that right here, 3 to the x equals 3 to the 5th, x has to equal 5. That's the property applied outright, but you're going to have to do it on more complicated ones. So you'll have to take each base and make sure it is the exact same. Then you can take your exponents and set them equal to one another. Okay? That's the end game here. You're going to turn your bases into the same number. These are all going to be perfect squares, perfect cubes, stuff like that. Turn them to be the same, set your exponents equal, and then solve the equation. Make sense? Everybody good? Everybody good up here? Yeah, okay. First one. Too soon. Okay. First thing you have to make sure those bases are the same. Okay? And they're not. Right? You have 2 to the x equals 8 to the 3rd. Jordan.
I was just going to say that
X is going to end up equaling 9. That's correct. All right. Here's how you get there. You have to make your bases be the same, right? That's the key to the whole problem. So your left side is 2 to the x equals. For these to work, 8 is going to have to be able to be rewritten as a base of 2. And it's 2 to the third. And that 8 is still to what power? The 3. So the 8 is 2 cubed. This 3 is that 3. Make sense? Not quite. Right? That's exactly it. You got power to a power now. So you multiply those powers. So 2 to the x equals 2 to the 9th. And now that you have the same bases, you can set your exponents equal. So x equals 9. The key is to make sure your bases are the same. Mr. Sullivan. Yes. All these numbers are going to be able to be rewritten bases of one another all day today. Okay? Mm-hmm. Otherwise they don't work. Otherwise it's a totally different animal that we're going to get to later. Okay? So these will all work today. Yeah, we're going to get to ones that don't this chapter, but not today.
Well, you have to break it down and stuff like that.
It's a whole different story. You got 9 to the 2x minus 1 equals 3 to the 6x power. So what base do we need to rewrite as? Need to rewrite the 9 as a 3, which is what?
I mean, no.
What did you say?
No.
3 squared. There you go. 3 squared. Still in chapter 6, dude.
Would you put that in for 2x?
I'm getting there. Okay.
Yeah.
I'm getting there, yeah. Okay? 3 to the squared to the 2x minus 1 equals 3 to the 6x. Okay? Now, power to a power, like Chamberlain was saying up here. That 2x minus 1 is a what? Starts with a B. It's a binomial. So, technically, yeah, you should probably put it in parentheses. Because when you do that power to a power, what do? You're going to distribute it. Okay, so you're going to distribute this 2 to the 2x and to the negative 1.
Are you squaring them or are you just
Multiplying. Multiplying. So 3 to the 4x minus 2 equals 3 to the 6x. All right. Everybody good with that? Slow down. Easy. Everybody good with that step? Okay. If you have a binomial up in that second exponent, you distribute it. Everybody good? You got bases of 3s, so now you can set your exponents equal. So 4x minus 2 from the left equals 6x from the right. Subtract 4x. Gives you negative 2 equals 2x. And divide by. Divide by. Let's attach to x. Change. Divide by positive 2. So it'll give you x equals negative 1. All right. Ron. Well, I'll do this one with you guys, then we're going to set you free on the next two after that, all right? So this one is 16 to the 2x minus 3 power equals 8.
Don't you have to change?
All right. So 16 is what? Okay, I'm going to go with these because I want to make that point. 4 squared. Right? We all know it's 4 squared. What's 8 though? 2 to the third, right? 2 cubed. Okay? You can't do it with 4 and a 2. So somehow, some way, you either have to be able to rewrite 8 as a base of 4 or rewrite 16 as a base of 2. You cannot just do the ones you're most familiar with. You know, 4 squared, 2 cubed, and make some magic happen. Doesn't work. Okay?
Can't you like
So-
rewrite it again?
So rewrite 16 as what instead? 2 to the 4th.
Write that on the sheet.
Okay? Rewrite 16 as 2 to the 4th. Whoops. To the 2x minus 3. And then rewrite 8. As 2 to the 3rd. The key are your bases, guys. They have to be the same. Okay? That's the key. Everybody see that? Distribute the 4 through. Which gives you 2 to the 8x minus 12 equals 2 to the 3rd. Set your exponents equal. That's okay. Add 12. And divide by 8. Whoops. So x equals 15 eighths. Leave it in progress. Okay. Fractions are commonplace here. Alright. Fractional answers are pretty common, so don't freak out because you get one. Alright. Questions up to there. So make sure whenever you're working these, 8 and 16 are pretty common. 27 and 81 are pretty common as your bases because you get them down to 3. And 81 could be 9 squared. You know what I mean? Okay, so those are pretty much your two common ones. Obviously, 64 is still a big number with these because you can do so many with 64. All right? Still watch that.
And all of that.
Yeah, still up to 216, more likely. Okay? Maybe a 343 now. 7 cubed. All right? Everybody good?
Listen.
Alright, so, like I said, if you want to change them to 2s, you can. You'll get the same thing. I don't like, if I can change one less number, I like to do that. Okay, especially since I wanted you guys to know that 64 was 4 cubed, right? It makes this problem a lot easier. Okay, it really does. It saves you a distribute on the left-hand side. It saves you a reducing step on the second part. Okay? So try to make it so that you see the bigger ones. That way you don't have to distribute. Make sense? So you got 4 to the 2n minus 1 equals 4 to the third. Add 1. Divide by 2. Maybe I should add 1 to the 3 there. N equals 2. Okay, right side. 5 to the 5x. 125 is 5 to the third. To the x plus 2. Distribute the 3. Set equal. Subtract 3. Divide by 2. X equals 3. I know. I know how you guys feel about fractions. I know.
Will these all be over 1?
Under 1.
Under what?
She said over 1.
She said over 1, and then I thought you said underwear.
I said under 1.
For the most part, yeah. Okay. Maybe a difficult one on the homework, maybe. But mostly, yeah, under 1. Okay. So you have 2 to the x plus 2 equals 1 over 32. Anybody got an idea? Rainy.
You gotta turn 1/32 into the rest plus.
Good thought, but no. Miss Dixon.
Make it negative.
Negative what?
32 breaks in because 32 has to go back on top.
32 needs to go on top.
Who do you?
So then when we move 32 up,
It goes.
we make the exponent on 32 what? Negative. Good.
Wait, what?
Chapter 5. Make the exponent. Okay? Because remember, hold on, I'll show you. Remember from chapter 5, you guys didn't realize back then chapter 5 was going to be such a big part of your lives. Remember this?
1
That's 1 over what?
x squared.
X squared. And 1 over x to the negative second gave you x squared. Remember that? Okay? That is a negative, yeah. Remember that? Those are two-way streets. Okay? Those are two-way streets. So I can move them down and make them positive. I could also, and this goes for this one right here, move it up and make it negative. See that?
One problem.
Move 32 up to the numerator, and the exponent on 32 becomes negative. Which gets it, yes, which gets it out of the denominator. Now what do you have to do?
Set the bases.
Get your bases the same. Good. So it'd be 2 to the 5th. 2 to the x plus 2 equals 2 to the 5th to the negative 1st. Which ends up being 2 to the negative 5th. Okay, if you want to go straight there, that's fine. All right, I don't necessarily need to see this step right here. Okay, if you want to go straight there, that's fine. Just make sure you can. Okay. You got them set up. So x plus 2 equals negative 5. So x equals negative 7.
Can we just do you mind if we skip step?
All right, here we go. Compound interest.
I just learned this away.
Okay. Yeah, this is a consumer ed topic, but to make Mr. Schmidt's life a little easier, I'd also do it here.
Wait,
Okay.
you can math in between.
Okay. And actually, I don't even know if I've talked to him about this, but I'm going to make you guys' lives really easy here in a little bit. And I maybe should tell him that I do this. Anyways, no, I should. You need to know this formula. Okay? You got to know that formula. you got to, let me circle it without going through the letters. You got to know that formula. You got to know what the variables represent. Okay? The formula for computing compound interest is A equals P parentheses 1 plus R over N, close them parentheses, to the N times T power. Okay? It's on your PowerPoint slides if you guys can't see that far up here. Okay, but that's what it is. P parentheses 1 plus R over N, close parentheses, to the N times T power.
Can I put that comment in?
You don't have to.
Oh.
Okay?
Wait, what is it?
Which part, Sam? NT, right here. The exponent.
Yes.
N times T.
We multiply it down to
Yes, you will.
W. Power.
Yep. Okay. Now, defining the variables. You have, what, 5 of them? 1, 2, 3, 4, 5, it looks like. A, P, R, N, T. Okay, let's go with the easy ones. What's R?
Rate.
Rate. Okay, your interest rate. Make sure it gets to be a, what kind of number? Starts with a D. D.
Top.
A decimal number. Okay, because remember, that's going to be given to you like 7.2%. Make sure you make it a decimal. All right. What's T? Time. Yeah, pretty much every single problem you ever do in here, T is time. Okay. The other three are kind of specific. All right. A, or here, let's start with this. P is called your principal. It's your starting money. It's how much money you take to the bank and say, I want to invest this. Okay? Starting money. A is your ending money. That's how much money is in that account after that many years at that rate compounded that many times. Whew. Did you get all that?
No.
Okay. A is what you end up with. All right? Okay. Your ending money, correct. Okay. The weird one's N. Okay, and here's why it's weird. In the text you can see it says the number of compounding periods each year. What that means is the interest you accumulate in this account gets added into the account so many times per year. So N is talking about the number of times interest gets added per year. All right, so I'm not really going to write anything. You can kind of make your own. I guess interest added to. Number of times interest is added. Number of times interest, I'm going to run out of space, is added. Okay. The key to that is to knowing how many times different units of time happen per year. For example, how many months are in a year? 12. So if it says compounded monthly, that would be 12. All right. Compounded daily, what would you use?
28 hours.
365.
Huh?
Okay.
Daily?
365. You use 365 for daily.
A year? Like daily?
If
What
it
about
says compound,
360?
if it says compounded daily, you would do 365. What about quarterly? 4. 4 quarters. Quarterly is 4. Okay. Those are your big ones. The other big one is weekly.
64.
52.
Oh,
Which blows my mind every year. How many? Yeah. 52. Okay.
Look, come on.
That's like,
All
It's
right.
52 weeks in a year.
Yeah.
I don't believe that.
Well, too bad. Okay? Now, obviously we're eventually, listen up. Obviously we're going to program that formula into our calculators here in a slide or two. Okay? What you need to make sure, though, because this is where I'm going to get your points from during a quiz or a test, is the setup to all of this. Okay? That's where I'm going to know that you know where these numbers go.
That's a question.
All right? So number one on these, an investment account pays 4.2% interest compounded monthly.
12.
If $2,500 is invested in this account, what will be the balance after 15 years?
You plug it in.
So A equals P, parentheses 1 plus R over N to the NT power. All of these in this part of the chapter, all of these today are going to be solving for A, by the way. Okay, we don't know what A is, that's what we're going to find every time. What's P?
When would it be different in this?
Later, chat, later. Okay, P is your initial money.
25.
It's 2,500. 1 plus. Now your rate's 4.2%. Make that a decimal number, so it would be what? 0.042. Compounding, it says compounded monthly, so N would be 12. And then the N is 12. Whoops.
Hold on. Why can't we just keep the 4.2?
15.
You wouldn't change it to months.
No. How many times does it happen per year? Okay. So there's 12 months in a year, so N is 12. Okay.
I would like to change it 15 years to match
15 stays years. Okay. Because that will be years. Okay. N is how many times it happens per year. T is how many years the money is left in the account. Because this doesn't happen overnight, right? Okay. Everybody good?
Distribute?
No. That's what I'm going to get to next. Making sure. Knowing your calculator, this chapter, guys, is super, super important, okay? You have to know this thing, how to do this backwards, forwards, left, right. All right, so 2,500. Okay, everybody got this down? It's going to go away.
No.
Okay. Okay, first thing I would do, I would get that exponent. Okay? So 12 times 15. Okay, 180. And then write that down so you know. Okay, so that exponent's 180. All right. Now, up here on the board, I'm going to write the whole thing down. Okay, 2,500. Yep. 1 plus 0.042 over 12 to the 180th power now, right? To make sure you do this and do this properly, you make sure you follow what?
What's it called?
Yeah. PEMDAS. Good. Your order ops. Okay. And within your order ops, you have to do what first? Parentheses. Exponent. Yeah, and then on down the line, right? Okay. Inside parentheses is 1 plus 0.042 over 12. So, hold on. So out of that, what goes next?
Oh. The answer?
No.
The division.
The division. Okay? So 0.042, I'm going to show you guys how I want you to do this. 0.042 divide by 12. Enter. 0.0035. Okay? Just hang tight, because that won't always be that nice. Okay? So I am, hold on. I'm right here. I got this number, right? Then what do I do to it? Add 1. Okay? 1.0035. Then what? Take it to the 180 power, which your caret's right above divide. Hit enter. Okay? Alright. Now, here's why I want you guys to make sure you do it this way. If you round this off and you round it off a few times, your answer is going to be super different than mine. Super different. So don't round until the very end. All right? Makes sense? Do not round until the very end. So now what do we have to do with this?
Times it by 200.
Times it by 2,500. Okay? $4,688.866166. So what's my final answer?
About
0.89.
87. There you go. $4,688.87. I don't have to tell you what to round to, because we're talking about what? Money.
So this is A.
This is A. That's it. Rainy.
Did you put the about sign?
You could. You also could not. I'd be alright either way. Alright. Let me explain. Okay? I want you to write the left side down. Okay, yep. I want you to write the left side down. Prompt P, prompt R, prompt N, prompt T. The space, colons included, by the way. Okay, colons included. You'll see why. P, leave a space. P, parenthesis, 1 plus, parenthesis, R, divide N, double close, caret, NT, arrow A, DISP, quote, amounts and account, enter, or, well, not enter for you guys, display A.
Last year we did law cosines and
Yeah, you're probably right. You probably should have done law of cosines before, so it shouldn't be completely brand new. Okay? But here's how this works, guys. I'm going to clear all this stuff, okay? First thing you want to do is hit program. All right? It is the key that's right above cosine. All right? See that? Now, you should maybe still have the quadratic one here that I gave you. If you don't, it's okay. But here's how this works. You're going to arrow over to new. So arrow to the right twice. Hit enter. That's new. All right, you're going to write a new program.
Which we need.
Okay. I named mine this. CM
Oh my God.
PD.
C. Where's the M? Where's the
Oh, watch. Hey. Look up there.
You said PD?
Okay. Hang on. Everybody relax. Calm down. Okay. CM
The N's the division.
P D I N S T. Okay. Notice how it gives you your alpha. It stays in alpha lock so you can go straight in. Okay. Compound interest. Program divide 8 x to the negative first x squared log natural log 4. Okay. Everybody see that?
When you're done.
Everybody, okay. Everybody there. Everybody good? Hit enter. Now, see why they put the colon in your code that you have? The colon pops up anyhow. Okay? So now you're going to start asking or telling the calculator that when we run this program, we want it to ask us something. Okay? That's where these prompt commands come in. To get there, if you wrote it down, you hit program, which brings you to this menu, which has a whole bunch of options. Eventually we'll get to some other things about this. You're going to arrow over to the right, which is your I/O menu, and see how prompts number 2? So hit 2.
Hit 2.
Hit 2.
Can we go down and press enter?
That's fine too. Either way. Okay? So now it brings up prompt. The first variable we want it to prompt us on is what? P. So now you find P in your alpha. Make sure you hit alpha this time though. Okay? If you want to hit a letter, that alpha, see that A flashing right there?
Yeah.
That has to be flashing for you to bring up your letter.
Then you put 8.
Okay? So put P,
8.
which is 8, right?
For sure.
If we hit enter, will it bring up another?
Hit enter, it goes to your next line. Now what do we want it to do?
Program again.
Program,
Wow.
prompt, right?
2.
2, and this time we want it to prompt us on
R.
R,
So that's X.
Which is-
multiply.
which is multiply, right? Prompt R.
Whoa.
Okay?
You press prompt
Oh.
Enter.
Wait, you push multiply?
Yeah, because multiply is your R when you hit alpha. Okay?
I'm too scared to do the rest.
Prompt, right? Or program, right? Prompt. Next we want it to do what? N,
Yeah. NT.
which is alpha log. Enter. Program, right? Prompt,
T.
T, which is 4. Enter. And then I leave that space. So hit enter twice after you're done with your prompt lines.
How do you do
I'm
that?
scared for this.
No, this is with 100% the most important part of the program. Because if this does not work, and this is where this takes practice, if your formula line does not work the way it needs to, right?
Right.
Okay? So that's why I'm going to walk you through baby steps, okay?
Okay.
Alpha.
Alpha.
You want P first, which is 8, right? That's what you wrote down. Parenthesis, which is above 8. 1 plus
Plus. Parentheses again.
parentheses again. Alpha R, which is multiply,
Ooh, almost messed up.
divided by
N.
alpha N, which is log. And how many parentheses did you write down after that?
2.
2. 1 for closing your division.
Close enough.
1 for closing the 1 plus R over N quantity.
Then you put 2.
Make sense? Okay. Now, what do we do to that? We take it to a
Power.
power, so caret, parenthesis.
Parentheses.
Yep, because you've got that multiplication in your exponent, right? So group N, alpha T, close parenthesis.
What's the T?
It's
It's 4.
4. All right, and stop there.
Whoa. I think I
It sent me down to the next
Okay,
one.
that's my point. That's my point. That's my point. Okay. Now, nice new calculator, colorful type people. You're about probably halfway to 2/3 through your line, right?
Yep.
Okay, great. You stay tight for a second. Older type people. See how the colon kept popping up here, but this colon didn't
Yes.
when it pushed us to the next line?
Mhm.
See that? So you're still technically in the same line of code. It's just your screen doesn't go that far. So you keep working it as if you are in that line. It's just pushing to the next one. See that?
Yes.
So everybody got the formula in correctly.
I think so.
All that is out.
That's what I haven't gotten the arrow yet. Okay.
You gotta
To
go
do the
there.
arrow, see the stow button right above on?
The what?
The stow. STO.
Yeah.
Yeah.
Hit that.
You see it?
Ooh.
Yep. It brings up an arrow.
Ooh.
Hey, look at that. Easy, right?
Okay.
Now, here's where this gets tricky. Ready?
Oh, no.
Okay. Anytime you have a formula, work it out, you have to send it to a variable. That way, whenever we want it to show us that answer, we can tell it to display that variable. Okay? So we had to set this to a variable. That's what that arrow means. We're sending this to a variable, and the variable we're going to pick is A, because the formula equals A. See how I did that? Yeah, crazy, huh?
Whoa.
Can we hit enter?
Now you hit enter.
Gotta
Okay.
get the cooler.
Now we go down to D.
Now you find, okay, so now we've written the program itself, written the code. Now we want the calculator, when it's done doing all that stuff, to spit out our answers and show us the answer. Okay? The next line, quite honestly, is optional. Okay? It's 100% optional. The line is this. Program, right, arrow down twice now for display.
Choice 3.
Okay? Yeah. You can have your calculator display like cute little text message to let you know what it is. For example, amount in account, like it has there on your paper, right? Okay? It's a lot of typing. It's optional. You don't necessarily need it.
Oh, we gotta write that out.
Yeah, because then you would have to go quote, which is plus, amount in account.
Do we have to hit
Do we hit
alpha?
for the quote?
You have to hit the quote.
Do we have to hit alpha plus?
Yes.
To get the quote?
Yep.
Okay.
Can we press it in A-Rock?
If
So
you hit
alpha-
second
yes.
alpha.
If you do second alpha, you get your alpha lock. Correct.
Yeah.
Okay, so I'm just gonna do money. All right. If you want to do something else, hey,
We need space too?
Money, wait, what's money?
I'm changing the code.
What's
Okay.
the space?
Can we do money?
Circle.
Can we do money?
You can do whatever you want.
Hold on, we
What
need
the
the
heck is
space.
circle?
Hang on. Okay.
Oh,
All right. Listen. The line that is not optional is this one. Program. Arrow to the right. Display. Alpha. A. Here's the differences. If it's in quotes, it's going to display that text. If it's not in quotes, it's going to display the value that's assigned to it right there. See that? That's the differences. Okay? If you messed up somewhere, one of two options. Come see me, or the whole entire thing's on video. Okay? Once you are finished with a program, you go second quit.
oh God.
Okay?
It's gonna save everything, right?
It's going to save everything. Okay? It saves as you go, which was my first worrisome too. Okay? It saves as you go. All right?